Welcome to the Explainer. Hey, if you're studying for that ACI Field Grade I exam, you have come to the right place. We're going to do a quick pop quiz, pulling questions right from the first two sections of the workbook to see what you've got.
All right, let's just jump right in. No messing around. We're going to start with one of the most important skills you've got to have nailed down on any job site.
So round one is all about sampling fresh concrete. You know, getting a good representative sample is pretty much the foundation for everything else. Get this wrong, and all your other tests are useless. You ready?
Okay, here's a classic. This is a critical time limit you absolutely, positively have to know. What is it? The clock's ticking.
15 minutes. That's the magic number. You get a 15-minute window, and that's it. And, you know, there's a really good reason for that rush. Any longer, and that concrete starts to change, meaning your sample won't actually represent the whole batch anymore.
Next up. So you're about to make some cylinders, for those big strength tests. How much concrete do you really need to scoop up? You need at least 1 cubic foot or 28 liters. Yeah, and you don't want to get caught short on this one. Grab any less, and you might not have enough material to run all your tests and make your specimens correctly.
Okay, so you did it. You got your whole sample collected inside that 15-minute window. Awesome. But guess what? A new clock just started. What's the deadline for those first crucial tests? 5. Just 5 minutes. That's all you get. Properties like slump, temperature, and air content, man, they can change in the blink of an eye. You have got to get on it immediately to get a true picture of the concrete that was delivered.
And this chart here, it lays it all out perfectly. You can see the whole timeline. You've got that max of 15 minutes to collect your sample. Then, boom, the moment that's done, you have 5 minutes to kick off your temperature, air, and slump tests. You get a little more breathing room, up to 15 minutes before you have to start molding those cylinders or beams. Okay, let's think about a real job site for a second. You got your concrete in the wheelbarrow. Are you good to just, leave it sitting there while you go grab your slump cone?
Oh, that is a big fat false. If you were leaning towards true, this is something you've got to burn into your memory. It's critical for the test, and even more critical in the field.
You have to protect that sample like it's gold. The sun beating down, the wind whipping by, anything that could contaminate it, all of that can completely change its properties. Just covering it up is a simple step that makes all the difference for your test results.
Nice work on sampling. Let's roll right into round 2, temperature testing. Let's see how sharp you are on these procedures.
This one is all about doing it by the book. We're talking about getting a real temperature reading of the concrete's core, not just a surface reading. So, how deep does that thermometer have to go? 3 inches. That's the number, and it's not just about plunging it 3 inches deep. You also have to make sure there's at least 3 inches of concrete all around the sensor in every direction. Seriously, no shortcuts on this one.
And look, you can see right here in this picture what that looks like. The technician is making sure it's buried right in the middle. If that sensor is too close to the side or sticking out a bit, the air temperature can totally throw off your reading.
Okay, so you've got it placed perfectly. You can't just jab it in and pull it right back out, right? There's a waiting period to get a stable reading. How long is it?
The sweet spot is right between 2 and 5 minutes. That gives the thermometer enough time to actually match the concrete's temperature. But you don't want to wait too long, because then the concrete itself might start to cool down or heat up.
All right, last question for this round. We know that in this line of work, precision is everything. So when you go to write down that temperature, how accurate does your number need to be?
You've got to record and report that temperature to the nearest 1 degree Fahrenheit, or if you're using Celsius, to the nearest ½ degree. Getting close just doesn't cut it. It has to be exactly to that specified accuracy.
And time. That's the end of our little pop quiz. So, how'd you do? Whether you aced it or maybe found a couple of spots you need to brush up on, let's do a super quick recap of the absolute must-knows.
So let's just boil it all down, shall we? If you can just remember these 4 things, you are in fantastic shape. It's all about timing, protecting your sample, using your equipment the right way, and being accurate in your reporting. You master these, and you've basically mastered the fundamentals.
And that leaves us with one final thing to chew on. Which one of these rules is the most critical? Is it the timing, the sample protection, the accuracy? The truth is, they're all links in the exact same chain. One tiny mistake in any of these simple rules could lead to bad data, which leads to a bad decision, and that could compromise the safety of the entire structure. That's why every single detail matters. Thanks for joining this explainer.